let's take a look at our tangent graph. So let's start by filling out our table. Now remember, negative pi halves is the same exact thing as 3 pi halves. If we look at our unit circle, if I go pi halves in the clockwise direction, that's negative pi halves or 3 pi halves. So if we're down there at that point, now we want to look at our tangent value. Remember that tangent is the y value over the x value. So we come here at negative pi halves, find this point, which is going to be 0, negative 1, and I do the y value divided by the x value, which is going to give me undefined. Now if we look at negative pi fourths, the tangent value there is negative 1. At 0, the tangent value will be 0. Y over x gives us 0. Pi fourths gives us a positive 1. And at pi halves, we get undefined again. So let's graph these points. At negative pi halves, I have undefined, which is an asymptote. At negative pi fourths, I have negative 1. 0, 0. Pi fourths, 1. And at pi halves, undefined, or an asymptote again. So this tangent graph actually looks like that. And once again, it is also periodic, meaning that it's going to keep repeating itself over and over again. It repeats this same kind of, it almost looks like a cubic graph that gets repeated over and over again. So this is our tangent graph. Now let's look at our key features. First off, our asymptotes. The asymptotes look like they start at negative pi halves, and they are all pi apart. So I add pi to get to the next one, add pi to get to the next one. My period is going to be different this time. Notice the length of one wave of this graph is no longer 2 pi wide. One wave is now only pi wide. So the period is only pi. However, we can still talk about the amplitude. It's different than it was before, because before we would draw our amplitude lines and our wave would fit inside those amplitude lines. This time, our amplitude is telling us where to put those 2 points. So if it had an amplitude of 2, we'd put it up there, and then the graph would be steeper. So that's where the amplitude comes in, but in this case, it is still up 1, down 1. The domain is going to be everything except my asymptotes. And my range, those y values, go from negative infinity to infinity. It's going to hit all the y values. And this is our tangent shape. So what I would like you to do next is you're going to take these tangent values, flip them to create the cotangent values, and then graph our cotangent graph to see what that looks like. So take these tangent values. Remember, anything is technically over 1. And then this undefined was 1 over 0. And then you're going to flip all those values, see what you get, and write it in the cotangent. Oh, and don't forget cotangent, we're actually going to start at 0 and go up to pi. So pause the video, fill in those cotangent values for those, and then come back to check and see if you got the cotangent shape correct. Let's check your work. So first thing over here at the table, these are all my tangent values for these radians. And I just looked at my unit circle for those. So I copied the tangent values down here so that for the cotangent, I could take those tangent values and flip them. So the tangent value here is 0 over 1. I flipped it to 1 over 0. That gives me undefined. And I did that for the rest of the points. Then I graphed them all to get my cotangent shape right there. So here is my cotangent shape. Notice that once again, the period is only pi long, not 2 pi. So for tangent and cotangent, the period is pi. Sine, cosine, secant, cosecant, the period is 2 pi. My asymptotes start here at 0, and then they're all pi apart, so 0 plus pi k are all my asymptotes. Once again, it is periodic. It repeats this shape over and over. I have my range, hits all my y values up and down, and my amplitude up 1, down 1 to get to those points. And that is our cotangent graph. Now, what I'd like you to do down here is to do a quick summary of all 6 graphs. So remember, our sine graph is our S wave. Our cosine graph is our C wave. The cosecant graph is the S wave, but it's been flipped. And we've got those asymptotes in between. The secant is the cosine wave, but it's been flipped. With those asymptotes. And now we have just learned tangent and cotangent. The tangent graph looks like this, increasing. And the cotangent graph looks like this. It's like the tangent graph, but now it's decreasing from left to right instead of increasing. So, a couple last minute things I want you to notice on this video. First off, all the graphs except tangent start on the y-axis and move forward. So sine, cosine starts on the y-axis, cosecant starts on the y-axis, secant starts on the y-axis, and even cotangent starts on the y-axis and moves forward. Tangent is different in that instead of starting at the y-axis and moving forward, tangent is the only graph that is centered on the y-axis, which is very different from the rest of them, and we're going to have to keep that in mind when we graph them with transformations, which is coming next. So just remember, tangent is centered on your y-axis. The rest of them all go from the y-axis and go forward. Next, these 4 all have a period of 2 pi. These 2 have a period of pi. Lastly, tangent is increasing from left to right. Cotangent is decreasing from left to right. So knowing all these patterns, these are the 6 graphs that you need to have memorized for 1060. Using these graphs in the next video, we're going to do some transformations of our tangent and cotangent graphs. I'll see you there.